Today we're going to introduce you to exponential growth and decay, and we're going to start that by collecting data. So it tells us here on trial 0, we're going to start with 2 M&Ms in a cup. So I've got 2 M&Ms in a cup here. I am going to roll these 2 M&Ms here, and we're going to look at how many come up with the M on top. On both of these came up with the M on top, so then we are going to add 2 now, 1 for each M. So now on our first trial, we are going to have 4 M&Ms. And so I'm going to take those 4 M&Ms and put them in the cup. Again, we're going to roll them. In this case, again, we had 2 M&Ms with M on top. The other 2 are the other way. So I'm going to add 2 more to my trial now. So now we've got 6 here. We're going to take these 6, put them back in our cup. We're going to roll those again. And I've got 1, 2, and 3 now that have an M on top. So we're going to add 3 to our trial now. That puts us at 9. I'm going to keep doing that here to finish collecting our data. We take all 9 M&Ms. We roll them again. Oh, got a little all over the table here. On this one, we've got 1, 2, 3, 4, and 5 M&Ms. So I'm going to add 5 to our trial. We're going to keep doing that so that I can finish filling out this table. All right, now that I've filled out my table, I got up to 96, and that's where we ran out of M&Ms, which is okay because now we've got a trial here that gives us enough data. The first thing we're going to do is work on putting this in the calculator and looking at to see what that looks like. And so I want to make sure that you have the steps in your calculator so that you're able to do that. All right, so we are going to go to Stat and then Edit. And in here, we're going to put our trial values. So in the L1, I'm going to go ahead and put my trials, and I'll start with that 0 on this one. 0, 1, 2, 3, 9. I'm not going to put the 10 in there since I do not have a value that goes with that 10. Now for L2, I'll go ahead and put my values that we got for the M&Ms. So the 2, the 4, the 6, all right, so each X value has a Y value now here. Everything is matched up, which is the way it needs to be, or it's going to give you an error message. So we've got our trials on L1 and then our total M&Ms on L2. To see this on the calculator now, I'm going to go to my Y equals, and I want to turn on the plot there. So we want to go to that stat plot. So you can highlight it and hit enter, and that will turn it on for you to see it. Or you can hit second Y equals and go to the stat plot menu and turn it on that way. So either one of those are options to get it turned on. Now I am going to adjust my window because the standard window is from -10 to 10 on both the X and the Y. -10 to 10 works on my X values because I just have 0 to 10 here. It does not work on the Y values because it does start at 2, but it goes all the way up to 96. So to see all those values, I would have to open up that Y value. So on my Y max, I'm going to go up to 100 so I can see every single point. And now we hit graph. Let me get that out of the glare. There we go. And here is our graph. Notice on there, it is not a line. It's not a quadratic like we've done either because it doesn't have another side here. It's starting right here, and then it starts to grow a lot quicker as we move this way. This here is called exponential growth. You've probably heard that quite a bit right now. Exponential growth. This is growing exponentially as it moves to the right. So those instructions are typed right down here for you to know that. Now to write the equation for this, we want to do that here. We've looked at the graph. There it is. Get rid of that glare. There's our graph. This is getting really close here, and then it's jumping up, growing very quickly right here. That's exponential growth. To get this equation now, we're going to hit stat. We're going to move over to calculate. So we moved that from edit to calculate this time. And this is where we're going to tell it what kind of equation. We said it doesn't look like a line because it doesn't have that constant rate of change, which lines have. It doesn't look like a quadratic because it does not have a left-hand side to this. And so then we've got our cubic regression, quartic regression. We know it's not the cubic. We've seen that one this year already again. But if you keep going down, you get to this 0 right here, which is the exponential regression. So exponential regression is what we're looking for. I'm going to hit enter. It's telling me the x is our L1, the y is our L2. So that is true. I'm going to skip right over that. Where it says store regression equation, that tells the calculator where to put the equation once it's written it. And so if you hit alpha trace, you can put it into the y equals somewhere. So I'm going to put it in the y1, and then I'm going to hit calculate. And here is our equation. So it tells us that the exponential regression model is y equals a times b to the x. It gives me the value of a right here, 2.45232, and b 1.508. Now, when we're working with equations, to write it down on paper, you can go ahead and round that to about 2 decimals. So you would want to put the 2.45 and the 1.51. However, to use the equation, you want to use the entire thing. You don't want to round when you're using that equation. That's why we plug it into the y1. If you go to the y equals now, the calculator put the entire equation there. That's what you want to use when you're looking for different values as we move on to asking questions. If I hit graph now, it is going to graph that equation. And if you look at it, that's an excellent equation. The calculator is just written there. See, it goes through every single one of those points, and we see that exponential growth. Notice that our graph here is getting close to our x-axis. So it's got an asymptote right there. We'll get to that later as we move on to graphing. But there's our exponential regression equation. So I'm going to go ahead and write that down here at the bottom of our paper so that we've got that. We said for our paper here, I can go ahead and write 2.45. And then that is being multiplied times 1.51 to the x power. I'm going to go ahead and sketch a graph there as well so that we've got an idea of what that looks like. All right, so now we've got our equation written and our graph sketched here, and we said this is an exponential growth. We're going to come back and talk about this in a little bit, but we're going to go ahead and do the second side here, where we're going to work this backwards now. So on our 0 trial, we're going to start with the 65. That's going to get us a good idea of what we're going to do. And so here with 65, we're going to go ahead and roll all 65 M&Ms. So I've got them in my cup here. I am going to roll them on the paper. Now, on this case, we are going to take out every single one of them that has the M up. Four, 26, 28. All right, so we're going to take away those 36. So now we only have 29 on this next roll. So I'm going to take those 29 and put them back in the cup. We're going to roll them, and we're going to remove the ones that have the M again. And I'm going to keep doing that as I move on with the different trials. All right, I went ahead and performed the rest of the trials here, removing the ones that had the M this time. So on the first trial, we were adding 1 for each M that appeared on the top. Here we're subtracting 1 for each time the M appears on the top. I stopped here when I had 1 because you really can't have a 0 value on these. The calculator will give you an error. So we're going to go ahead and put these in now. We're going to do that exactly the same as we did the other side. So I go to stat, enter. Now, since I've already got points in there, I need to clear them out. So I am going to highlight the L1 and we're going to hit clear. That's the button right below the arrows there. You do not want to hit delete because then it'll delete the L1. So you want to hit clear on that L2. And so now we've got an empty slate and we can go ahead and put our new values. Now, technically, I guess I shouldn't have deleted the L1 since those were the same. The L2 are the ones that are important to change here. There we go. Oops. 3 and then 1. There we go. So now that I've got all my data into the calculator, again, I'm going to want to see it. The window that we had is still going to be the same. So I'm going to go ahead and hit graph. And now we get a graph that looks like this. And so our values start up here. Oh, I forgot to remove the other graph. Sorry about that. Let me take out that Y1. There we go. All right, so we see our first point is up here, and then it starts to go down and it gets really close to the x-axis here. This is considered an exponential decay because it's going down. The other one was an exponential growth as it grew this way. This is an exponential decay. You'll hear this talked about bacteria growth, viruses, and all that stuff goes on an exponential growth or decay model. And we'll look at those as we move forward in this unit. This is just an introduction, so we're just introducing you to these exponential graphs. This is an exponential decay, we said, as it's going down. Now when I hit stat, I'm going to move over to calculate again, and I'm going to go down to exponential regression again, which is the 0. I hit enter. Again, we're going to want to store that regression equation to verify that it's a good one, so I'm going to hit the alpha trace there, and those are typed on your notes in case you forget those steps. So we hit enter for that Y1 and then enter to calculate, and it gives me my equation there. Again, we can go ahead and round that, but don't round it when you're using the equation. So let's go ahead and write that down on my experiment 2 here. That was y equals 45.26 times 0.676 to the x powered. Now when I hit graph, it is going to go ahead and graph my new equation. And that is a really good equation as well. It is going through most of our points, but it verifies those points as it goes through them. I'm going to go ahead and quickly sketch a graph there so that we have that on our paper. All right, now that we have a graph there and an equation, we can go ahead and look at it and talk about a couple things as we're interpreting these graphs. The calculator told you it was y equals a times b to the x. So that's what we want to compare there is those two. If we look at the a here, it is 45.26. If we look at the a on this first one, it was 2.45. There you go. You can't see that. Y equals 2.45. So we want to think about those values and what they mean on this equation. On this trial, it started at 2 and then it started to go up here. Our trial on the backside here started at 65 and then started to go down. If you think about what the calculator's done there for that A value, it is close to where you started. It's an average of where you started basically. Because the calculator is finding an average. Since this is real life data, it is not always going to come out to be an exact number. So it didn't come out to be 2 here, but it's pretty close, that 2.45. So that A value is your initial amount. That's what you're starting with. Now, if we look at this next value, the one that's being raised to the power, it tells us 1.51 on the front side. On the back side here, it is 0.676. Well, we want to think about that. When it's multiplying times 1.5, then it's causing that growth. When it's multiplying times a fractional number like this, 0.676, it's getting smaller. So that's what causes that decay. So that B value there is the growth or decay factor. When it is bigger than 1, it's going to be a growth, and when it's between 0 and 1, it's going to be a decay. X is your exponent. Most of the time, that's going to be time, or the number of rolls in this particular case, and then Y is going to be the total amount. So we're going to go ahead and summarize that real quick on this paper just so that you have it. Again, today's really an introduction, so we're just introducing to you this equation and graph. So A is going to be the initial amount. B is the growth or decay factor. X is your multiplier. That's basically your time is usually what it is, or the number of rolls in this case. And then your Y is your total amount. You should be able to identify now if it's going to be a growth or decay. This right here, it is decreasing, so this is exponential decay. It is decreasing. And then this right here is an exponential growth. It is increasing. Again, what tells us that is the number that is being raised to the x power. So when your b value is between 0 and 1, it is going to be a decay. When your b value is greater than 1, it is going to be a growth. Now a has to be unequal to 0. Because that would make the entire thing 0. A is also your initial amount. So it is going to give you that y-intercept. So that is our growth and decay models. You just saw the one with the M&M as it was growing and decreasing. Make sure you understand that this B value is that growth or decay factor, and it tells you which one it is. So at this point, you should be able to determine what causes exponential growth, what causes exponential decay. You should be able to identify that on the graph as well. You should know this is an exponential growth, this is an exponential decay, because this is decreasing, that one is increasing. Again, the growth factor or decay factor tells you if it's a growth or decay. If this is bigger than 1, it's a growth. If it's between 0 and 1, it's a decay. The A is the initial amount, how much you started with. So in our trial here, if this was a perfect world, we started with the 2, and then it would double each time. That's what you're getting here. Since it's real life data, it didn't come out to those exact numbers, but this was our initial amount of 2, and then this is close to that doubling every single time, which is our exponential growth. That was an introduction to this new unit. As we move forward, we're going to go further and deeper into these exponential growth and decay growth.